So x by 3 minus y by 3 equal to 1. And for the third equation, before this, let me just write this, that because we need to keep this sign as a plus sign, what we'll do is we'll write this as x by 3 plus y by minus 3 is equal to 1. And for the third equation, we divide both sides by 15 to get x by 15 plus y by 3 is equal to 1. Okay. So now we can graph these. Okay. For the first one, x plus y is equal to 3. This is your corresponding equation. So you have 3 here and you have 3 here. So that means this graph will pass through 3, 0, and 0, 3. I'll join these 2 points. So this is my straight line. Okay, which is the straight line represents which equation? X plus y is equal to 3. Next equation here is x minus y equal to 3, whose corresponding equation we have got here as x by 3 plus y by minus 3. So here you have, so this will clearly pass through, sorry, this is on this point. In fact, if you see below x, you have a plus 3, so it will pass through 3, 0 definitely. And below y, you have a minus 3, so it will pass through 0, minus 3. 0, minus 3 is here. So this straight line will be our required straight line. Okay. We'll write the equation here. The equation here is x minus y is equal to 3. And third one, x plus 5y is equal to 15. Corresponding equation is x by 15 plus y by 3 is equal to 1. So below x you have a 15, so it will pass through 15, 0. Let's say 15, 0 is somewhere over here. And 0, 3 it will pass through. So that means it will pass through these 2 points. So this will be your straight line. Okay. So write the name of the equation here. X plus 5y is equal to 15. So now once we have drawn these 3 lines, we see that each of these lines divides the entire xy plane into 2 sides. One is the origin side, the other is the non-origin side, right? Consider the first equation. X plus y minus 3 equal to 0. Okay. So we have x plus y minus 3 equal to 0. For x is equal to y is equal to 0, that is the point origin, that is the origin. What do we have? X plus y minus 3 is equal to 0 plus 0 minus 3, which is, what is the equality sign here? Greater than. We are getting this as minus 3. Is minus 3 greater than or equal to 3? Yes. Is minus 3 greater than or equal to 3? Yes. So therefore, which side will be shade? We'll shade the origin side, okay, of this line. So therefore, the origin side of this line, let's shade it. This side. All these form the solutions of this inequality. Next one, x minus y. Consider the next inequality here, x minus y less than or equal to 3. Consider the equation first. So we have x minus y minus 3 is equal to 0. Again, take the origin. This is greater than or equal to 0. This should not this. Is minus 3 greater than or equal to 0? Because I've taken everything on the right hand side, left hand side. So here you have 0, minus 0, minus 3. What is the sign here? Less than or equal to. So is this less than or equal to 0? Okay, so this is false. Okay, I have my mistake here. This should not be the shaded part. This minus 3 is greater than or equal to 0. This is wrong. This is no. This answer is no. Therefore, we have to shade the non-origin side. We cannot shade this side. You will have to shade the non-origin side. This inequality is not satisfied for x is equal to 0 and y is equal to 0. So for the first line, we'll shade this part. Shade this way. Fine. For the second one, as you are doing, 0 minus 0 minus 3 less than or equal to 0. So is minus 3 less than or equal to 0? Answer is yes. So therefore, which part will we shade? We are going to shade the origin side of this line. Which one is the origin side of this line? This. All this is the origin side. Okay. All this is the origin side. And finally, the last equation. X plus 5y is equal to 15. So we have x plus 5y minus 15 is equal to 0. For x is equal to y is equal to 0. That is the origin. Put it here and check whether it satisfies the inequality. 0 plus 5 into 0 minus 15. How much are we getting? Minus 15. What is the sign of the inequality here? Greater than or equal to. So is it greater than or equal to 0? Yes.
No, sir.
No, wrong. Sorry. This is minus 15 greater than or equal to 0? No. Therefore, we'll shade again the non-origin side of this line. So which one is the non-origin side of this line? This is the non-origin side. Right? All this is the non-origin side. So what is the common shaded area? The common shaded area, if you see here, is formed by this. this part. Can you see this area? All this area, this is the right. So this part forms the solution. So in the graph, you will shade this part. Is it absolutely clear? Or any question you have? No question? I think I've solved enough problems for you to have any question from this part. We'll solve the last part of this problem, of this exercise that I had sent you. Now here, the problem is just the opposite of the problem we have been doing. That is, in all the problem that we have done earlier, the inequalities were given and we were to shade the area, right, which form the solution. In this part, the area that is shaded is given to you and you will have to form the inequalities. Okay, the lines are given to you. So let us list down the lines first. Now remember, before listing down the lines, whenever you are given this kind of a problem, you will first make the right hand side of each of the equations positive. Okay. So we have, what are the equations given here? 3x plus y minus 6 is equal to 0. Next, you have 4x plus 9y minus 36 is equal to 0. Next equation is 4x minus 3y minus 12 is equal to 0. And you have x plus 3y minus 6 equal to 0. 4 lines are given to you, right? You can see in the figure. Now, the first thing is that this entire set you will have to rewrite such that the right hand side here is positive. Okay. So you can write this equation as 3x plus y is equal to 6. We have made the right hand side positive. 4x plus 9y is equal to 36. Again, here the right hand side is positive. 4x minus 3y is equal to 12. Right hand side positive. X plus 3y is equal to 6. Right hand positive. So making the RHS of each equation positive. Okay. Now, once we have got the RHS positive, now what we'll do is we'll see which side of the line is shaded. Consider the first line, 3x plus y is equal to 6. Which one is the line here? This is the line, right? If you see which part is shaded, the origin side or the non-origin side of this line. If you see for this line, the non-origin side of this straight line is shaded, right? Now, when the non-origin side is shaded, that means you will take, since you'll write, since the non-origin side of 3x plus y is equal to 6 is shaded, therefore we'll say 3x plus y will give a less than or equal to sign here. If the non-origin side is shaded, we'll give a less than or equal to sign. Okay, so this shaded part represents this inequality. Consider the next equation, this one. If you see, which one is the equation of 4x plus 9y is equal to 36. I think this is the line here. Okay, if this line, which side is shaded? The origin side is clearly shaded, right? Since the origin side of 4x plus 9y is equal to 36 is shaded. Therefore, what should be the sign of the inequality? It should be a greater than or equal to. 4x plus 9y is greater than or equal to 36. Origin side. Similarly, since consider the third one, 4x minus 3y is equal to 12. Which one is the line here? This is the line. Okay, if you see, then origin side is shaded. So therefore, we'll give a greater than or equal to. Since the origin side of 4x minus 3y is equal to 12 is shaded. Therefore, 4x minus 3y must be greater than or equal to 12. And finally, the last one, x plus 3y is equal to 6. Which one is the line here? This one. If you see, the non-origin side is shaded. That means the sign will again be less than or equal to. Since the non-origin side of x plus 3y is equal to 6 is shaded. Therefore, x plus 3y must be less than or equal to 6. Oh, this is just the reverse. Okay. If the non-origin side is there, then this sign will be greater than or equal to. If the origin side is there, then this sign will be less than or equal to. Remember this rule, okay? Sign will be less than or equal to. And this sign will be greater than or equal to. So what have we done here to summarize? First of all, we have listed the equations. From these equations, we have made the right hand side positive. See, all the right hand side we have made positive, right? Now, once we have made the right hand side positive, now we see which side of the equation is shaded of each of the lines. 3x plus y equal to 6. The red line is there. You see that the non-origin side is shaded, right? If the non-origin is shaded, we'll insert a greater than or equal to sign. So in here, there will be a greater than or equal. That means what are the inequalities? Similarly, if the origin side is shaded, we'll introduce a less than or equal to. So therefore, what are the inequalities? The inequalities are represented by the shaded part are 3x plus y greater than or equal to 6. Next, 4x plus 9y less than or equal to 36. 4x minus 3y less than or equal to 12. And x plus 3y is greater than or equal to 6. So that is your answer. Okay, so this part I conclude here for linear inequalities. Now, last part is left, which is called the quadratic inequalities. Okay, that part we'll start. Now, quadratic inequalities, now linear, what have we done? Till now, we have done linear inequalities in one variable, right? We have done linear inequalities in two variables, right? Now we'll do quadratic inequalities in one variable. Okay. So this is the part that I had sent you, if you remember. We'll start with the first one. This is the type of question that you're going to get. Now, before I start with this, I just remember one thing. I just would just like to discuss with you something called as the method of intervals. Now, what is this method of intervals? Suppose you have factors like x plus 2 into x plus 5 into x minus 3 into x minus 2 less than or equal to 0, whichever. Okay, say less than or equal to 0. So what should be the range of values of x? What should be the values of x? Now, in this case, what you will do here is we'll be using this in quadratic inequality. So please remember this method of intervals. What you'll do here is you'll put x plus 2 is equal to 0. You'll put x plus 5 is equal to 0. X minus 3 is equal to 0. And you'll put x minus 2 is equal to 0. So what you'll get here is x is equal to minus 2, x is equal to minus 5, x is equal to 3, and x is equal to 2. This is what you are getting, right? So now what are the negative values of x you are getting? Minus 2 and minus 5. Which one is the lower value among the negative values? Minus 5. So we say, therefore, for this inequality, x must lie between minus 5 and minus 2. Not only that, now we'll consider these two positive values. For these two positive values, you have 3 and 2. So that means which one is the lesser value of 2? Positive value 2. So that means x must also lie between 2 and 3. So what are the solutions of this x? That x can lie between these two values, minus 5 and minus 2, and x can also lie between 2 and 3. So this is the solution of this inequality. Is that clear to all of you, or you need this to be explained? Okay, so I hope this is clear. First one, quadratic inequalities in one variable. The first problem here is determine the range of values of x for which. So we have 2x square plus 3x minus 9. What is the replacement set of this inequality? Can you tell me? What is the replacement set? Anyone?
Sir, minus 6 or 3.
Why minus 6? Replacement set. Replacement set is what are the values that x can take. I told you earlier that if replacement set is not mentioned, you will take it as a set of real numbers, right? So the replacement set has here is
Yes.
the set of real numbers. So x belongs to R actually. Okay. So now what you do here is, if you're given this kind of a problem, first you will factorize this. Okay. First of all, you're going to factorize this. You have 2x square plus 6x minus 3x minus 9 less than or equal to 0. That means you get 2x into x plus 3 minus 3 into x plus 3 less than or equal to 0. That means you get x plus 3 into 2x minus 3 less than or equal to 0. Okay, which you can also write as x minus 3, and this you can write as twice x minus 3 by 2. Okay, so this is twice x minus 3 into x minus 3 by 2 less than or equal to 0. So now by the method of intervals, what are the range of values of x? Which one is the lower value?
Minus 3.
Minus 3. That means because I have a less than or equal to sign here, x must lie between minus 3 and 3 by 2. So that is your answer. So this was the simplest of all. Next one, number 2. Question is determine the range of values of x for which x square minus 2x plus 5 divided by 3x square minus 2x minus 5 is greater than half. What you do here is you first of all, the first step will be to make the right hand side 0. Minus half. You make the right hand side 0. Now you take the LCM here. Okay, so if you take the LCM here, you're going to get 2x square minus 4x plus 10 minus 3x square minus 2x plus 5 greater than 0. That means I open the brackets and you simplify, you'll get minus x square minus 2x plus 15 divided by
Sir, there will be minus 5 in the numerator.
minus 5 in the numerator. Why minus 5?
Yes, sir. Sir, where you have taken the multiplication of by dividing 2, sir, there will be in bracket 3x square minus 2x minus 5.
Okay, this should be minus 5. So that is why this becomes 15. Okay. So this means this is divided by 3x square minus 2x minus 5 is greater than 0. That means now from the numerator, if you take minus common, we get x square plus 2x minus 15 divided by 3x square minus 2x minus 5 is greater than 0. So now if you multiply both sides by minus 1, the inequality sign will reverse. You get x square plus 2x minus 15 divided by 3x square minus 2x minus 5 is less than 0. The inequality sign will reverse because I have multiplied both sides by minus sign. Okay, so this means you factorize the numerator and denominator now. Okay, so this is x square minus 3x plus 5x minus 15 divided by x square minus 5x plus 3x minus 5 is less than 0. That means the factors will be x plus 5 into x minus 3 divided by x plus 1 into
Sir, you
3x
missed
minus
out.
1. Which one?
Sir, you missed out 3 in the denominator.
3x minus 5. Okay, fine. So now you see that I have factorized the numerator and denominator. Now what we'll try to do here is we'll make the denominator positive. How do we make the denominator positive? By making the square. So what I'll do here is I'll multiply the numerator and denominator by x plus 1 into 3x minus 5. So I get x plus 1 whole square into 3x minus 5 whole square in the denominator less than 0. Now see if this part is clearly positive always, right? For whatever value of x you take. And if this entire fraction is negative, that means the numerator must be negative. That is why the fraction is negative. That means x plus 5 into x minus 3 into x plus 1 into 3x minus 5 must be less than 0. Right? Now we apply the method of intervals. That means what are the values of x we are getting? Putting x plus 5 is equal to 0, x minus 3 is equal to 0, x plus 1 is equal to 0, 3x minus 5 is equal to 0. We get x is equal to minus 5, x is equal to 3, x is equal to minus 1, and x is equal to 5 by 3. And what is the sign here? Less than or equal to. So first we'll take the whatever the negative values. What are the negative values here? -1 and -5. That means x must lie between -5 and -1. And what else? What are the positive values? 3 and 5/3. And x must also lie between 5/3 and 3. That is the solution. For these values, this inequality will be satisfied always. Okay. Just give me a minute.